just like me being recorded. Okay. So I've got two copies of the FP1 file. One of them is showing frequency, the other's trying amplitude. If I click fit to screen, top left, it says 6 hours. That's kind of too long to see much, so I'm going to make it 30 minutes, show from start. Okay, so this black and white line is the temperature. It's really useful. It's showing you big swings here. That tells you this pod is in the air. And um, obviously, all the cetaceans it records while it's in the air will be false. There may be some, but the classifier is not trained on rejecting the things it hears basically from your local radio stations, etc. So at some point here it goes into the water, and it's probably just here where it's the angles shown by these little white lines change abruptly to being more vertical. So I'm going to click there, set selection start. So this is now about cropping. So there's a video online about cropping. Um, and this is just to show how, so you can see here it keeps going off for short periods when it's hanging downwards. The lines are in red, that tells you it's off. So you've over here, it's off for a longer period. Um, so you need to look at every file because you do discover some quite surprising things like long off periods, which you might not have expected, or even just periods when it's horizontal. Okay, so here's our checklist. So that's, is it immersed? Is it exposed? Is it on? And then is the noise profile as expected. So here there's kind of the quickest view of noise is this black line down here, which is the total number of clicks logged. The green line is how the pod responds to that by sort of raising its detection thresholds. Um, and here you've got some episodes of noise which are not like dominating the picture. And we'll do another session sometime on like diagnosing the causes of bursts of noise. But you need to look at that because you may find some files where it's just incredibly noisy throughout, and it really isn't going to work as a piece of acoustic monitoring. Okay, so you crop the file and you put your cropped FP1 files in a folder called useful files. This is a really good idea, the useful files folder, because it's what you work on forevermore after that. So once they're in there, you get the FP3 from each file. That's done via the trains page here where you click detect click trains in FP1 files, runs the kernel-F classifier. Okay, so then you have to assess whether validation is needed. And it says here, view FP3 classification warnings. Okay, this file, we didn't have an FP3 here. I'll just close it again, see if we open a file set. Was there an FP3? Yes. Okay, so the FP3 is now open. We can then go to the filters and files page, and this stuff is over here, bottom left, classification warnings. So you can look at these from FPOD files where they're very good warnings, CPOD files where they're not very good. Other FPOD files, ones that aren't open, and other C files. So here we'll just have a quick look at this one. So files 3 and 4 are the FP3 files. So if we go back there, either 3 or 4 will tell us the same thing. So it says it's got an excess of slow dolphin trains, risk of sonar errors. So it's got file warning of 2. But what I'm going to do is show you getting the whole list, because you might have a lot of files and you want to know, are there some here that you've already got that desperately need validation? So we'll go to Britain cat. And here we've got a long list of files from the cat project. So I want just FP3 files. And I kind of select them all to open. Okay, I can't actually see what it's doing because of the zoom bar at the top. Oh, results are on the clipboard. Okay, so I need a spreadsheet. Get a spreadsheet. And Control and V. That has given me the classification warnings for however many files it is. So which they are, the explanation of them is listed there. And I'm just going to sort these by risk sum, because that's really useful. So sort that Z to A. So some of these have got a risk sum of 8. That is absolutely terrible. That means it's almost certainly got loads of errors in it. So you need to do this with all the FP3 files you've got. Down the bottom here, it says this file needs updated warnings report. See trains page of the menu. So you particularly if you've got a project that's been running for a while, you may well get lots of warnings like that. So for that, you have to go to the trains page, and there's a button here, generate version 2 file warnings. And if you click that, you can select all the FP3 files. It doesn't have to rerun the Kerno F classifier. You do it on the cropped files. It's very quick and it gives you really good warnings. So these warnings are actually they're actually very useful. And if I get the document up, yeah, it says more about how to use them down here. Down here, so we'll come to that in a minute. So you're going to view the warnings. 4 and higher are usually bad. It doesn't mean the whole file is bad, but it means it's almost certainly unwise to just use the results. And then I've got a second point of view the FP3 analysis and compare with saved examples. So I will just, have I got any files open? I've forgotten where I am here. Oh, spike validation. That's
Nick,
here.
quick question from Emily. Is there a limit to how many files you can show the warnings for?
Nope.
No.
The Samba project had 1,400 files. We kept them all in one directory, and that worked beautifully. But you could have 10,000 in one directory; it would work fine. Yeah. That doesn't read across directories, so it's much quicker if if you have got them all in one directory, then you can get them all out. Yeah, so files. Okay, so this file I've already got open is it's a very nice file. It's been cropped, so I'll just show you what it looks like. Well, this is kind of once you've got the FP3 file based on your cropped file, the initial view that I go for is you have narrowband high frequency, that's porpoises, dolphins, sonars, and unclass. You select higher, moderate quality, and low quality. This isn't what you use in your analysis, but it's a good way of seeing like what this file is like. If I hit fit to screen, it'll say 6 hours, but that's quite long, displays quite slowly. So I'll do 30 minutes, show from start. Okay. So this is like really nice when you've got the results. You can see the unclassed species is the grey, and if the data is generally good, the grey is generally associated with a species, and by species I'm including sonar. Um, just here you can see it says a little bit of sonar, a little bit of unclassed, a little bit of porpoise. So it might be it's got an error in there, but that was 30 minutes if I zoom in. But well, a little bit too far. There's the sonar, there's the unclassed. The porpoises were kind of rather separate. Okay, so it's good when you don't have a lot of unclassed associated with the species, because then it means it's a bit like a porpoise or a bit like a dolphin, but sorry, I'm flipping around a bit faster and it may not refresh. So you expect to get a certain amount like that, even like that, but not an awful lot more. And similarly here, the quality class, the green is low quality, which means the classifier's not absolutely sure it was a click train, but they're clustered together with the good stuff. So this is like very reassuring. If you find they're very different, then you've got sort of something to worry about, which means you may have to do detail validation. You can go to the analysis page and then you look at one of the categories you would normally be sort of analyzing for. So here, say we want to analyze for porpoises, we'll only use high and moderate quality. File 3 is an FP3, that's okay. Analyze. Okay, whiz bang, 1 million and whatever porpoise clicks found. And then we're getting a lot of detail about those clicks. So this is a really useful reference. If there was something really odd, you might well be able to pick it up here. What might be really odd, say if you had a sonar exactly at porpoise frequencies and a lot of it was creeping through in here, then you might find that the number of cycles was sometimes like 100. This is where the frequency peak is. The amplitudes mostly quite low, but some high ones. The bandwidth is very low, and this is the click rate profile, which is really useful. That's typical of porpoises. And this section here for 20 to 1200 has just been multiplied by 10, I think it was, just to make it so it doesn't all, become hard to read. So that all looks good. And we've put a clip of that on the end of a document that Dan will send you. So you can use it as a reference of what you might expect porpoise data to look like. This thing, the operational threshold, is kind of a measure of noise. If there's a lot of noise, here it was mostly in the 0 to 1, you could get peaks up here. So that's telling you something. Does anybody want to ask any questions at this point? I'm kind of racing along here. If you raise your hand, hopefully Dan can pick it up. Yeah, Jacob, give us a question.
I'm not sure if it's completely related to validation, but it's just an idea that popped into my head. In the histogram, the clicks per second histogram in red, bottom
Yeah.
left there of the analysis tab, there's a paper, I forget the reference now, where the frequency distribution, like of the peak frequency of echolocation clicks for belugas is unimodal, and for narwhals it's bimodal. So like if I was trying to find or get hints if there was narwhals mixing in with my data, I could consult that histogram, and if it had a second peak, like that, if that was a bimodal distribution, I suspect narwhals could be around.
Yeah. So yeah,
Is that
actually,
is
there's
that
a
a
better
correct
way of
usage?
doing it than looking at this, which is you display the whole file. Um, I won't spend too long on this, Jacob, because it's a really good question, that a lot of people um, will share. But I'll just point out, I'll actually, um, yeah. So the paper you're referring is referring to the frequency in kilohertz of the clicks
Yep,
rather than the click rate.
yep.
Um, so you can get better graphs than on the analysis page to give you that kind of depth of detail that you're looking for, and you can export the numbers in them, um, which may be useful. And when it's finished creeping along there, I will show. So you go to the display page, you go to this section on graphs. You want to omit the FP1 because that's got noise and everything, and you want, say, kilohertz, which is what you were interested in, clicks. And so you just hit the, and it was kind of going to be the dolphins, hit the graph button, and it's now reading the FP3 file, and it's giving you a better graph of click rates because it's got a log axis there, and it's giving you the frequency distribution. Um, okay, so we'll come back to that species discrimination stuff in another session, Jacob. I'm sure there'll be a lot of people interested in that. So we've looked at the low resolution view. We're looking at distribution of unclassed and low quality trains and noise patterns, looking for major unexpected noise events. So that was that black line going along the bottom with the green line. And we will do another session on diagnosing or identifying the causes of noise bursts and what they might mean. Um, so at this point, um, you've decided that that file at least didn't have any bad stuff. The low quality and unclassed trains were nicely clustered together with the good stuff, so that file is not giving you any warnings. Um, and then once you've done this, you can decide whether you need to validate a file in detail. And so I've got 5 reasons why you should do that. One is you need experience because you've got to look at a lot of normal stuff before you can decide you can skip it. Or the site is new to you. If you've never seen data from this site, you definitely want to look at it. If the risks sum on those classification warnings was going above 3, and probably even if it's 3, or you should do it. Or if you found any of these unexpected features, like uh, the analysis didn't match what you expected, or if there are less than 150 detection positive minutes in the whole file. So, when you think about it, if there are no porpoises, your error rate has to be either 0 or 100%, and it'll probably be 100%. because you probably will get like one click train that the classifier thought was a porpoise. So if there are very few detections, you want to look at all of them. So now to do this detail value, you're going to switch to high resolution view. And if you were sort of focused on some unexpected feature, like there was a patch of a noise at a particular, you could actually dive in and look at that. But for these others, you're basically going to go through the whole file, either looking at every porpoise or every dolphin click train or a sample of them. So I have got a spike validation sample. Okay. Fit to screen, show from start. So this spike word means this is a file that is an artificial file that we've constructed, like a butcher's spike. It's a reference to butchers, at least in Britain, used to have a thing with a metal spike, and they put all the paperwork on that, complete with bits of blood and fat and whatever else. We do it rather more neatly. So this file has got some dolphins, some porpoises, some dolphins, some sonars, and then what's weak unknown train sources. And then it's got a section which is supposed to have false trains that didn't come from anything that makes trains. They came from noise. But actually, the Kernow classifier is really very good at rejecting those. And I tacked on some stuff that I thought would show it up, but when it was mixed with those, the classifier said no, that's all rubbish, and refused to show us any trains. So we'll start at the beginning anyway, and so for this, you really want 3 copies of the FP1. The FP1 tells you more about the errors than the FP3 does. So you never try to validate just looking at the FP3. Because the thing is, this classifier wants to find good trains. So guess what? It finds good trains. You look at them, you think they're all good. It's only when you look at the FP1 that you realize it wasn't so good. So in the FP1, you want to look at, for starters, say frequency, amplitude, train Q class. That won't be any good because the FP1 doesn't know about that. So we'll make that number of cycles. We're not going to be interested in the species class because we're just going to do, say, porpoises initially. So they're always going to be porpoises. So we'll look at amplitude there and clicks per second, okay? And we'll look at them. Well, first of all, we'll just find how much of this we've got in this file. So that's porpoises, high and moderate quality. We don't want the low quality, because this is kind of what we're going to use for our actual data analysis. So file 4 is an FP3. It's got 1,500 clicks. It's only 11 detection positive minutes. So we've got to look at all of those. And we'll just, there's not much point in looking at the classification warnings because this was a sort of synthetic file, but I'm kind of interested. I don't think I've done this. What is it going to say? Risk of what? Excess of very fast dolphin chase. Oh, that's interesting. So
Does everyone here know what a what is, Nick, or do you think it's worth briefly?
yeah, good
mentioning
point.
them?
Good point. So whats are weak unknown train sources. We do not know what they are. They could be a little crustacean, it could be like the size of the head of a match. It could be sitting right on the hydrophone, cleaning its teeth or something and making a sequence of noises that do come in a click train. And occasionally they come in their thousands. And we've known about it for 20 years, and we've never eyeballed a Watts. And I'm thinking of putting out a prize for the first person to photograph a Watts facing into the camera, or even sideways. So yeah, and so it's only pod users who ever see them, but they are there, they are real, they are in acoustic data, and one day the WAV file community will see one, and they'll probably classify it as a dolphin, but I shouldn't be coming to disparaging conclusions. Okay, so say 10 milliseconds resolution. Joe from start. Show next screen. So it's seeking in file 4, which is an FP3, and it will whiz along until it finds the first click train that's allegedly a porpoise. And kind of here it is. It's got features we really like it's got a rounded amplitude profile. And that is because these cetacean click trains, the cetacean's got a narrow sound beam, weak at the edges and loud in the middle, and it's sweeping it around the world. And when it crosses the hydrophone, it's weak at first, and then it gets louder, 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 and weaker, 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 and disappears. These dots are telling you where the loudest cycle is. So it's somewhere between cycle 2 and 4, which is okay. Porpoises are generally later than cycle 1. Dolphins generally have the loudest cycles. So you have to think of the wave, the click as a series of waves. And in porpoises, it builds up and fades out. In dolphins, it starts loud and fades out. So when you see this, that's kind of looking quite good. There's the frequencies look right. You can hit the graph button here. It says the frequency is 125, click rate 15. That's okay. And we could down here look at this thing, narrowband high frequency index. So that goes from 0 to about 15. Values above 3 are really strongly suggestive of porpoises. So this is getting high scores. So at this point, I would zoom out and look for more. So if I go earlier, so I'm going to move, if I hit the left arrow key, yeah, there's nothing much showing over there. So show next when it comes back. If I go to the right, okay, it's getting more and more, getting really loud, massive porpoise detections, and then it fizzles out quite quickly. So that is a classic encounter. I think it was the whole of that. So an encounter is like when the pod first hears this single or group of porpoises come along. At first they're distant and weak, and then they're getting louder and louder. And when they go past, they disappear much more quickly because they don't send much sound out of their back end. You know, it makes a lot of sense. They want to learn what's in front of them. So if we look at the click rates here, these are kind of quite normal sort of click rates. There's something quite fast here, which is interesting, and we don't really quite know what that would be doing, but it's a subject of a lot of interest. And Jess Jones, who's on the call, who's doing a PhD on social communication, which involves these fast click rates. So a thing I wanted to sort of pick out here is that in this graph, the amplitude over the whole file, you get the the data coming in these lumps as the beam sweeps across. If the beam stays on the hydrophone for a bit longer, you typically get ripples in this, which is because the beam is actually still moving up and down, even if it's not moving sideways, and it's moving up and down because of the tail beat of the porpoise in this case. So you can actually figure out the rate at which porpoises beat their tails up and down. Comes out at something like 2 a second, or but obviously it does vary. Okay, so this is just to give you like a baseline of what normal stuff looks like. So we do we go back to 100 milliseconds, show next screen. Well, we're going to move off porpoises onto dolphins came next. So if I do show next screen, we've now got dolphin data. So just, I said if this thing now, but if it was above 3, that was quite suggestive of porpoises. Here it's getting up to 6. It definitely isn't a porpoise. So it's not, it doesn't decide everything for you. And I'm going to put frequency back in there. Refresh. Okay, I'm going to scale this graph down with F6 so that we get the top. So here, if I move to the left, we've got like nothing much happening here. And then as I go to the right, okay, we're getting a lump of stuff there, which, yep, is some kind of click train. It wasn't identified as a dolphin click train because it's not, or at least it was identified as a train, but it wasn't classified as a moderately certain dolphin train. So we're moving to the right, and you can see we're getting maybe a bit more louder stuff, and then it's kind of what have I done? Have I shown next screen? Okay, we get into the detection proper, where the animals are now getting quite close. We're getting high amplitudes, and we're seeing. So we're seeing this is very typical. This kind of lumpiness with gaps. This is the beam sweeping thing, with kind of relatively quiet between the beam crossing the hydrophone. And I'll zoom in on this one by dragging across it. And what you're seeing here, this is absolutely not a porpoise, even though it's got porpoise frequencies, because it's got low frequencies associated with it. And if I zoom in on those few clicks, they're showing us the what we call the multipath clusters. So after a click, you can get a number of clicks following it quite closely in time, but they can spread over even 20 milliseconds. And the frequencies in that cluster are frequencies present in the sound beam of the dolphin. So it gives you, even though the click picked out may just have one frequency, this bunch of clicks tells us a bit more. So if we hit the graph button, yeah, we can see these lower frequencies are coming packaged in with it. When I say packaged in, that is in here, they're tightly associated with the loudest click that gets into the or whatever click does get into the click train. Okay, so that's multipath. Multipath is extraordinarily useful. So you know, four of us here at Chelonia, we've been sort of having sessions trying to improve our skills at working out what's what, because this is a sophisticated skill that we're sort of talking about everybody acquiring here, and a multipath is something that is kind of really useful to know about. It actually shows up often as these vertical lines in the frequency display. So the reason they aren't exactly vertical, what it is after each of these loud clicks, you've got this multipath cluster which fizzles out quite quickly. But it gives you this vertical array of multipath replicates. They're very valuable information, you know, and if you use sound traps that offer you the option to just collect sound snippets, you don't want to use it because it'll only get you that first click and you'll miss the multipath cluster, which is very sort of diagnostic. Okay, so that's what dolphins look like, and we'll then buzz along to the sonars. So sonars, they have a very different look. You know, if you remember this is a whole minute, and what we were seeing was lumps of clicks from the beam sweeps. Here, there is no sensation of a beam sweep unless you take it as being 1 minute long, which could be the time this boat took to whiz past. But so that long, relatively flat profile is strongly indicative of a sonar. So is a sort of very narrow band of frequency, but porpoises will do that up there, and dolphins sometimes do that. So there's another test here. If you're kind of thinking, could this be a sonar? You might change that to clicks per second. Do refresh, and now you get this flat line, and it goes through several minutes here. And that is absolutely diagnostic of boat sonars. And it's often particularly clear out at the end where the boat isn't yet necessarily producing any click trains that the classifier finds. And here, if I zoom in at the top, this is a kind of odd sonar. It does this zigzag of click rate. And so down here, the interval between just one click and the next is getting shorter, longer. So you get a sort of double line there. So this view at of the clicks per second in the FP1 is incredibly useful. It can nearly always tell you, yep, that is a sonar. So here's another one, like dead flat line there. Another thing is how long the clicks are. So here they're very long. I'm scaling that down. They're actually as long as the FPOG doesn't let them be more than 255 cycles long. It then sort of starts another click, which will be kind of hidden in there. Yeah, whoops, go back to that.
Right.
Hello? So here we've got a the classifier is saying it's a sonar, and it's finding that, but there's a lot of low frequency noise that isn't multipath clusters, it's just scattered around. So you can't see the click rate down here. You can find it if you want to. You go to filters and files, and you, for click filters, because there's only clicks here, no trains, you say it's got to be at least, what should we say, 50 kilohertz, refresh. And now it's just got rid of the noise, and now you can see that flat line. So I will remove that filter before I forget about it. Okay, so that's what sonars look like. They don't have the lumpy structure from the Beam Suite. They do show a persistent interclick interval even outside trains. And yeah, so we've got more, just at a glance, you'd say that's not dolphins because it doesn't have that lumpy structure. And it's a sonar, yeah. Maybe just whiz through the sonars just in case we put in something else there that was okay. This one does look a bit lumpy, but it is giving you this flat click rate up there. And we're thinking, we don't really know, but we're thinking that this lumpiness could be the boat rolling. So the boat is rolling on the sea and it's swinging its sonar back and forth across the seabed, and that is creating this sort of periodic variation in the amplitude. Okay, no more clicks in file 4. So now we want to do unclassed. And we'll just fit to screen, show from start. Okay, so we're over here somewhere now. This is the section which has got WUTs in it. Weak unknown train sources. So they might be classified as anything. So I'm going to allow all of those in and zoom in on this. So we'll make file 1 shows frequency. You want to get used to just changing these all the time to whatever suits your needs. Can put a number of cycles in there. This has got off the scale up there, so I hit F6 to bring that down. So that's going from 84 clicks a second down. So this thing, it's clearly a train. So it is a train source. It's not a lot of clicks from shrimps because they're not a train source. They're a bunch of individuals doing their thing that may by chance fall into a regular sequence. But when we look at the whole thing here, you can see the amplitude profile is quite weak. It's under 100. It's not one of those rounded humps. It's sort of at both ends. It's still about the same intensities, maybe. So it's got a sort of flattish profile. The really distinctive thing for this one is it's got this low frequency start here, and then it goes along and ends. And it's got this very simple downsweep structure. That doesn't stop it being a porpoise, but you really wouldn't say this was a porpoise because of the so the frequency, the mode's at 108, which is very low for a porpoise, and it's going down to 90 and below. So that's not fitting with it being a porpoise. Okay, so this is a WUTs, show next screen. So here's another one a bit similar. I'll kind of whiz on to this one's rather similar. It didn't have that low frequency start, but it did have this curved rate descent. That's very typically WUTs. It did have the flat profile. The modal frequency was 105 and it was going too low. So so that's Oh, and the other thing is when you try and find, by going earlier, I can't really do it here because we just clip bits out, but you can't find an encounter. Okay, so here's one to yeah, so this thing has got an amazing structure of sort of varying click rates, but it's got this long flat profile and it's got different frequencies at the start. Okay, so hopefully that's given you an idea of what the normal appearance of these things is. So then we want to look at some actual files. So if I do, did I do that? Yeah, so what I did was export a bunch of the warnings. So these up here at 8 and so on, they're very high. And I think we can give them a miss, but we'll take this one, which is in there, and it's scoring quite high on the risk score. So files, open a file set, fit to screen. Sorry, I want to. Oh no, it's. I've I've lost the part of the view here, which enables me to. Okay, I'm just going to stop it because it's going to take too long. Just do the analysis for purposes. File 4. It's got 176 detection positive minutes. The amplitude's exclusively very low, so that is a bit of a worry. Let's look at the dolphins. It's got 147 detection positive minutes. They're also quite weak. And what warnings did we get from this? Very high instance of sonars at narrowband high frequency, very fast dolphin crane. Yeah, so fire warning 6. Okay, let's just try the porpoises first. 100 milliseconds, show from start. Show next screen. Oh, actually, we've got to look in file 4, haven't we? File 4. So it's proposing this as a porpoise. This has got this downward frequency sweep, and gosh, I'm running late here. It's not got any kind of encounter around it, so it is quite a nice humpy profile, but it's isolated, and I think we have to. I've kind of sorry. And I need another FP1. And another FP3. And we'll get click rate.
Just to say, Nick, if I don't know if you're intending on giving people a couple of minute break to yeah, if anybody would find that helpful.
Yeah, okay.
Yeah,
Well,
do you reckon?
we'll just pause here.
Okay. Yeah, should we
yeah.
just say yeah, like sort of 3 or 4 minutes or something?
Or alternatively, are people happy to press on? Luke, if you've got no questions coming up, Dan, maybe I'll keep going.
Some people may have already popped off to the toilet.
Sorry, was that a question for me? I was just talking to Sibylla, who's just left.
No, it was,
Right.
I was asking you, Dan, whether you thought we should press on or just giving people a comfort break. If so, those who are still here, when you look
I
at
thought
the,
people might need an eye strain break
okay,
and staring at the tiny pixels. But
yeah,
maybe that's just me. Yeah, I think I said 3 minutes. Yeah, so Sibylla is still co-hosting, but yeah, she's had to leave. So if you need
right,
anything done, ask me and I'll dash next door. For some reason she can't transfer the co-host to me, so
right.
just letting you know.
So I can make you the co-host.
Ooh.
Okay. Okay, so this has got that very smooth down sweep, relatively flat profile, bit of a freeze. That's a what? And actually, as we go into this file, it turns out, oh, we'll get rid of the low quality ones, that all the porpoises in this river actually were what's. So that was a bit of a shock. This one, this is sort of classic with the rapid frequency change at the start. They also, another use is they don't generally have any multipath. Here it looks like there is a little bit. Those pairs look rather similar. This doesn't look so similar because the spacing changes enormously. But okay, so then we'll look at the other cetaceans in this file. And guess what? Most of them turn out to be what? There's the low profile, there's no larger encounter. So what's actually, they're not common, but occasionally they occur in very large numbers. So I'll just actually show you a file where that happens. So this is in the Northeast Pacific. We've got 3 copies of the FP1, 3 of the FP3. And if I do show from start here, and I'm including unclassed and all this, you get this. So you've got sonars, porpoises with perhaps rather a lot of unclassed, dolphins. This is kind of okay until it gets to here. And suddenly when it gets to here, the amount of unclassed, the weight starts increasing. And it's associated with is with very high click rates here. So this color here, aubergine or something, says very high click rates. And we get to a point here where the classifier is saying, I really hardly know what any of these things are. Meanwhile, the amplitude scale here is saying not much happening. When there are loud events, the blue end of the spectrum starts coming down. the duration as number of cycles is getting longer and longer. So there's some really odd event going on, and if we dive into this, um, uh, uh, um, we can see that actually this is composed of a load of watts. Yeah, so I'll just so these are very short, very fast trains, like 800 a second. It's changing, sweeping the frequency through the train. Here, there's not much of a frequency sweep, but there's that same neat downslope there. And yeah, here you've got a bit of a frequency, but you haven't got much multipath. So we've only seen a few of these events, a number where this came from, one near here at Plymouth, and we're just calling them Watts storms. So that's just something to beware of, and that's why you can never just assume the classifier got it right. Okay, so we've now looked at, say we're going to do a formal validation. We can open a file set and we'll pick a reasonable file. So this one here from the Isles of Scilly near here. So you've decided you need to look at a sample of trains. So say you're going to check porpoises, or actually we'll do dolphins first. You've got your high and moderate dolphins only. You go to the filters and files page. Oh, you've got a files. I just do show from start.
We'll get MBHF on.
You've got to, oh yeah, I've got MBHF, thanks, Callum. Select a file for action, the FP3. Set validation sampling points, find 100. Well, I'll just make it 50 for our purposes here. So you do that, it reads through the file, it sets you 50 positions and says you can now use Control and S to move from one to the next. So they're correctly spaced in sort of statistical terms. So you use Control and S, and now you've got to decide, is this a dolphin? So you've got a nice lumpy profile, lot of we know the species, so I'm going to make that clicks per second. Normal sort of click rate. Yeah, so that's good. Control and S. So what I'll do, is just show you the speed at which I would do this, having done, I'd say good, 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 etc. And I'm applying the sort of criteria we've discussed, plus the more set out in a paper that Julia Vanchkova wrote on the basis of the Black Sea data. And I cooperated on that, and we've set out what we think are the key features, which we've already talked about. But I recommend her paper as a resource for doing the validation. So actually on this file, if you do 100, there will be 0 errors. The error rate is very low in this data. So if we change to porpoises, it did actually list the times of those 50 sampling points. And if you ask it not to randomize the positions, then you could have two people and they would be given the same same selection of trains to look at. So we'll do set validation sampling points. Now it'll be for porpoises. So it's done that. And so again, I can use Control and S. And I can zoom in and out, you know, so I've got like rounded profiles, right sort of frequency. I might kind of move a bit backwards and forwards. Oh, that's a fish tag, by the way. You know, one of those tags used to track fish. They're very characteristic. Show next screen, that takes us. Have we got any more coming along? Yes, it gets loud. So we've got an encounter, Control and S. Okay, here's some quite fast click trains. They're not showing that very neat down sweep. They are showing a rather neat up sweep. And these are quite weak. So we'll kind of look earlier. I'll just zoom out a bit and see if there was anything. There's that, which is clearly a click train, but it's got a rather flat top to it, and I'm not sure that is porpoises. Show next one, that will take. Oh, and then later, okay, we have got louder stuff here. Yeah, and this is looking very normal for porpoises. It's got these nice rounded profiles, good click rates. So so I'm going to accept these mainly because there was good stuff coming along later. If there wasn't, I would be seriously in doubt, actually. There's 3 trains, or was it 4? Yeah, they look like one, which is nice. So maybe I'm being a bit overcautious there. Okay, let's go to the next one. So you could even count that as narrow. This one is much stronger. We can look at the narrowband high frequency index, refresh. Okay, that's quite low there. So that's a note of caution. So let's just make this show us frequency. Yeah, so we are getting a lot of multipath, but it's staying kind of in the porpoise frequency band, which is good, you know, so it's giving us a similar modal frequency to the clicks in the train. So although the narrowband high frequency didn't like it, I'm kind of happy with it. We can sort of see a bit more of what the narrowband high frequency looks at, which is the frequency profile and the amplitude profile. Yeah, so the amplitude profile is flattish, which means the click's got a lot of cycles, and the ones before and after the peak are similar. The frequency's dropping rather a lot after the loudest cycle, and that actually is something this software doesn't really. We know actually now know that porpoise clicks are down sweeps. You can see it in the FPOD data. Okay, I've got to do Control and S to get to the next. So here's a porpoise click, and it looks like there's more. there's more coming. But essentially, this is the sort of process where you move through the data at these fixed points, and you write down how many of them you think are wrong, and get a percentage of errors. If you want to, you can mark the things that you're doubtful about. So if these trains here you thought were unsure, you right click and it says mark this train, and if you click yes, it will mark all the trains that can be seen. Mark trains excluded. So now you can't see that, but if we do mark trains only and we go to analysis, analyze file 4, it says it's only got 54 clicks. Those are the ones we had marked, and these are their characteristics. Okay, so I'm sorry, this is a lot to crush into one session. So what I've done is written this document, and it tries to explain the kind of logic behind what I've been saying there, and sets out the process you do, and it gives you sort of samples of what these analyses would normally look like. So it won't be a lot of help to people who are dealing with, say, different dolphin species, might show, this is the analysis that might show quite different things here. Jacob's belugas up in Ungava Bay will look quite different. But it does give you some idea of like how to do this. So at this point, I think what we do basically is I'm happy to answer any questions, and I would encourage you to tell us what you'd like more detail on, and we'll organize these one every month. And if you've got problem data, we're very happy to see that and go through that online with you and anybody else who wants to look. Okay, so
I think
any-
2 people did actually send some data through for this session, so it could be that we start with those.
yes, that's right. We've got one data which was on are these porpoises in the Baltic? Yeah. Okay. All right, so we can end it at this point if nobody wants to ask any specific questions, but absolutely please do send us your questions, and we will either answer them in person or set up a meeting like this. Jacob.
Yeah, okay. So I really liked that was clear how to judge a train.
Actually, I'll maybe
And
just stop recording here so that oh, can I? Yeah.